All right, so we have talked about mechanical advantage, ideal mechanical advantage. Um, Mechanical advantage. What two variables does that rely on? Okay, the forces. And that means that ideal mechanical advantage. What was ideal mechanical advantage? The distances. That's right. So if we have the ideal, which is what the machine should do, versus the just the mechanical, which is actually what the machine does do, then we can use those in a ratio as well. We'll talk about that in a second. What was our efficiency equation in our lab? That's right. Workout divided by work in times 100. We've already known that. Now, we can also, now that we know MA and IMA, we can also use a ratio between the two of those. Because remember, efficiency is what it should do versus what it actually does. Right? And that's where our mechanical and ideal mechanical advantages come into play. So we have MA divided by IMA times 100. All right, so those are all our equations. Now let's talk about our types of levers. There are three classes of lever. That's right, there's three classes of lever. Now, depending on how they are set up, how the lever is set up, like where the fulcrum is, where the effort is, where the load is, will determine what type of class it is.
Right. Fulcrum plus load or plus or U?
No. It doesn't necessarily mean closer to, it's just in proximity as far as what order they are in. Okay, so there's a mnemonic device that we are going to use. Come on, Noah. Oh my gosh, this is before I. Hold on just a second. All right, so we have our FLE 1, 2, 3. Now, F, L, and E stand for fulcrum, load, and effort. Whereas 1, 2, 3 obviously stand for our three classes. So they match up in this order. So the fulcrum matches up with first, load matches up with second, and the effort load or matches up with third. Now, whatever it matches up with will determine what is in the middle of this lever. The middle is a relative term because it's not going to actually bisect it or be right in the middle, but it's going to be in between the other two. So, the fulcrum is going to be in the middle for a first class lever. Okay, so only one of these, the fulcrum is going to be in the middle. That means second class, what's going to be in the middle?
Load.
The load. And then the third class is going to be the effort in the middle. And I'll show you examples. We're going to be drawing levers. Next slides. So this makes sense. So this is a really easy way to identify what type of lever something is. FLE 1, 2, 3. If the load is in the middle, it will be a second class. Fulcrum in the middle, first class. Efforts in the middle, third class. All right, so we're going to draw our lever, our three classes of lever, and label your efforts. Remember, you have your forces. You have your effort force, resistance force, and then you have your distance resistance and your distance effort. So we're going to go ahead and label all those. So you have a visual aid. And hopefully we finish this, so we can start our lab tomorrow. Not many. I think we only have like 3 left, or maybe 5 left. Moving on. All right, so class 1. Crowbar. What's in the middle? The fulcrum. Now notice when I say middle, it's not actually in the very middle, but it's in between the load and the effort. So what's going to be on the left side here? Okay, the thing you're lifting, right? So the load. And what's going to be on the right side? The effort. Now don't go ahead and don't write these down again. You've already written them down. I can put those up there as a key. So go through and lay. What's this down arrow going to be? That's right. Your FE. What's this up arrow going to be? Right. FR. Then we have our distance here. Remember, your distances always have to go from your fulcrum. So what's this distance going to be? It's on the resistance side, so yeah, it's going to be dr. And then finally, we have the rest of the length of the lever.
Distance effort.
Process of elimination, and one left. Our D. Okay? Bless you. All right, so our second class. What's in the middle?
Load.
Load's going to be in the middle. Example, wheelbarrow, right? So we're going to have a fulcrum at the end. For example, the wheelbarrow, what is our fulcrum?
A wheel.
The wheel, yeah. Where's our load going to go? Yep.
Does the effort supposed to be going up?
Now, I drew the arrow underneath. Does it have to go underneath? Does it go on top? Yeah, just as long as it's going up, right? Doesn't matter. So what would this be?
Effort.
Yep. FE. What is this up arrow going to be?
Bar.
Force resistance. FR. Now, where would the distance resistance be?
The whole bar. Oh, wait. Where's the, from the fulcrum
It's always from the fulcrum
to the load.
to the load. Very good. The distances always have to start at the fulcrum. All right, what is your distance effort going to be?
From the load to
The load to FE, is that starting from the fulcrum? Like I just said, it has to start from the fulcrum. The entire lever. It has to start at the fulcrum, guys. Starting at the load is not the fulcrum. Okay? Even though your brain wants to say that it starts at the load, that's not the pivot point. Always the distance has to be at wherever your transfer of energy is. Okay, and that is at the fulcrum.